Hello audience. I have got an opportunity to work on a project SQL Server 2000 Always On recently with one of the company, and I did some research online and used YouTube to get some information from different folks who have thrown some good material. And at this time I've completed the project and I want to share back what my research end up to be, and I want to give back what I learned and how I pursue the project. So this is the time to give back to the people who actually need some help on Always On. In this video I will cover basically the requirements given to me and the approach that I took to provide the solutions to the requirement. I used this project is basically a DR and high availability solution that they currently have, and the solution is that how can we use to enhance an existing solution. For any question that you have, please shoot me an email. My email address is au90remote@gmail.com. In this project, I will not go through the installation of Always On. And basically, in this project, I will be focusing on the requirements that I gathered and how I pursue to solve their problem in terms of what they want to achieve. However, if you are interested to install the Always On, I have put together some bullet points and some references to see on YouTube. So the first thing is that you have to have Windows 2008 or above. The slide is not right. You need 2008 or above, not 2008 R2. So there's a correction. Number two, you have to be in the Windows AD environment, and you should have a Windows cluster. It's not a typical SQL cluster that you need. That was a requirement for a SQL failover cluster. But for Always On, all you need is Windows cluster. Then you need as many IPs as you have the number of nodes in your cluster. So you have 2 nodes, then you need 2 IPs for those 2 nodes. You have 10 nodes, and you have to have 10 IPs. And then you have to have 1 IP for Windows cluster. And then for a listener, you need 1 IP for each listener. So if you have 1 listener, 1 IP is enough. But if you need 2 listeners, then you need 2 IPs, so on and so forth. Listener is a terminology that introduced in Always On is like virtual name, like in cluster that you have virtual name that you use for any client to make a connection to. In Always On, they have used the listener, which is same as the virtual name. The order of installation will be listed here. You need Windows on each node first, then you need to set up the Windows cluster, install SQL servers on each node, and enable Always On. You can install SQL servers in any order, but you can only enable Always On once you have the Windows cluster ready. That's the point that I want to make. Then you can set up the Always On. And setting up Always On is not any different than setting up mirroring, very close to how you set up mirroring. For you to see how you can install the Always On, there are some good material, good videos that I use to learn so many things in Always On. They are listed here. There are 4 parts, so if you are interested, feel free to watch these videos and learn 9-yard how you install an Always On. So here is the current setup, how the high availability and disaster recovery is set up in the company. There are two apps, and I call it app 1 and app 2. We have a primary site, and then we have a standby server on the primary site, which actually updated by log shipping every 15 minutes, and then we have a secondary site which is mirrored. It is async mirror, and mirroring does not allow for any read connections to be made. So this is just a standby idle server sitting there, ready for to fail over manually. So this is the new solution with always on. You will be using the same setup, except that now we are using always on. Always on is an improved version of mirroring. We will be using always on and replacing log shipping to update the standby locally and to update the DR site remotely. But the advantages are that you can use the read-only copy for any reporting purposes, and you also have an options to not disconnect any existing connections when you update the data, and you can do the two options, sync and async. Sync is real time, and so your primary and secondary, if they are set to be real-time sync, then their data is up to date. I just want to add a quick note here that always on is improved, and improved in the sense that they are now using the log cache thread on the primary and secondary, so the commit is gone through the log cache instead of hardening the log record on the disk. So it is fast and faster than definitely mirroring. So this is an improvement. I just want to add a slide here so to make a note. So this is the quick comparison between mirroring and always on this particular client, and I will go through the current solution and then what we will achieve using always on. The first bullet point is possible automatic failover. Currently there is no witness server, so you cannot do automatic failover. However, with always on, our intention would be to set up synchronization replication locally and async replication remotely. So you can do automatic failover remotely, but for you can do automatic failover locally, but you have to do manual failover remotely. Failover. The second bullet point is failover requires application to reconfigure connection string. In the current solution, you do require that because it's manual failover. So the switch that mirroring offers failover partner is not applicable. So you for a client to make the connections to the right server, they have to change the connection string. But with always on, if it is failed over locally, you don't need any connection string to be reconfigured. In fact, since we are using listener, we don't need to change the connection string, the server name, if we do fail over to the remote site. Third bullet point, real-time data at standby server for reporting. With log shipping, you don't have this option. It is every 15 minutes or how frequent you use the log shipping, but in our case 15 minutes, so it's not real-time, 15 minutes delay data, but with always on it is real-time. Number 4 bullet point is refresh data at standby needs users to disconnect. So so what will happen, let me go to that bullet point, if you give me just a second. There is something that I want to draw here, and I just want to make sure that I am good there. Uh, so refresh data at standby needs users to disconnect. You have to disconnect the users in the current solution, but for always on you don't need to. The next bullet point is same server name in connection string when reading data, reading standby for reporting purposes. Uh, in the current solution, the server name has to be different in the connection string, but with always on, you still use the same listener name. I will show you that in the demo, which is coming up, and you will know what exactly this bullet point means at that demo. Next bullet point is same server name in connection string at local failover. You will be using the same connection string if you use always on. However, in current solution it's not allowed. And if you fail over, you will be still using the same connection server name in the connection string, which is your listener name. Then all will be shown in the demo. The last bullet point is offload backup jobs. Always on offer this functionality that you can make the two types of backups on any of the secondary, and those two types are your copy only backup and the transaction log. Full backups and differential backups are not allowed to be made on any replica, but copy only and transaction log backups you can make on any secondary replica. So here is our demo. So we have two applications, app 1 and app 2. App 1 is holding one database instance, app 2 is holding a second database instance. In our demo, we'll be using the server name. I'm using the last four characters of the server name here, but the actual server name is different. So POC1 is holding a default instance which app1 will be using. That is the primary instance, and POC2 server is holding the app2 SQL Server instance. In case of local disaster, for instance if POC1 server goes down, then app1 instance will fail over to POC3 server. And in case if POC2 goes down, then the instance will fail over to POC3. So in a situation where POC1 and POC2 both instances gone down, then your POC3 will be holding a copy of SQL Server instance on POC3. So app1 and app2 will be connecting to POC3. Now POC3 is an exact copy, POC4 is an exact copy of POC3, except that the difference is on the primary side it's a real-time replication and automatic failover. It's a sync. However, on the secondary side it's a manual failover and is async. So that's the only difference. In case the whole site goes down, primary site, the secondary site will be up with one server, POC4, which will be serving app1 and app2 connections. Now we have created, or we have created two virtual names, which is the listeners, and the listener names is iOS instance and DM instance. So iOS instance is the app1 instance and DM instance is the app2 instance. So just to clarify, the first instance, iOS instance, is pointing to POC1, POC3, POC4. So primary place of app1 instance is POC1, but if POC1 goes down, it should fail over to POC3, and then if POC3 and POC1 goes down, it should move over to POC4. You can fail over from POC1, POC3 to POC4 manually if you want, but POC4 is actually on the DR side. Same thing true with DM instance, which is hosting the app2 instance. The only difference is the primary residence of app2 is POC2, but if POC2 goes down, it will automatically fail over to POC3. You can, however, fail over manually from POC2 to POC4 if you want. But if in case POC2, POC3 goes down, then you can manually fail over to POC4 in case of the site disaster. Now let's talk about the disk requirements. Basically, I say it is Windows cluster, not a SQL failover cluster. So no need for the shared disk. You need shared disk for SQL cluster. For Windows cluster, you don't need the shared disk. And for always on, all you need is the Windows cluster. Windows cluster is basically replacing the witness server, and the cluster will be used for witness. It is not recommended, but it is advisable to use the same drive letters that you have on secondary, which you are using on the primary. So obvious reasons that you want to keep the drive letters same is because what if tomorrow you want to add another file group on a different drive letter at primary, then you need to have the same drive letter on the secondary, because the changes that you are making on the primary, if it flows to the secondary, and at the secondary don't have those drive letters, your always on replication will fail. So in ideal situation, you don't have to add the file group, but if in case you do, then you have to keep it in the mind that the drive letter is available on secondary. In our case, we have E and F for POC1 holding app1 data, and there is no G and H drive. On POC2, we are using G and H drive for app2 data and log. POC3 have all the drives E, F, G, H, and POC3 and POC4 are exactly the same in terms of number of drives and the letters that we're using. So the reason why POC3, POC4 have E, F, G, H is because POC3 and POC4 can hold both app at a given time. As I said, there's no witness server. Windows cluster has replaced witness server role. It's good to discuss about the quorum configuration, which is an important part of Windows cluster. There are some good documentation available. I just thrown this slide there for you to know what do you need for quorum. Basically, quorum is the best practices that you should have an odd number of votes. So each so let me step back and to tell you what kind of quorum that you can define. You can define a node majority quorum, you can define a disk majority quorum, you can also use a shared quorum. For Windows cluster, which you need in always on, if you have odd number of nodes, then or you are thinking that you will be using a vote for odd number of nodes, then you should use a node majority. Most of the time it's node majority, but if in case you have a situation where you have even number of nodes, then you can have shared disk vote, which make the vote number of votes odd. So you have to have the odd number of votes. In our case, we have 4 servers, but because the fourth server is on the secondary side and we don't rely on the network because of the latency, we don't consider or we don't want to add problems if the POC4 is not responding back because of the network. So we have given the POC4 0 volt. However, POC1, 2 and 3 have 1 volt each. So in our case, we are good if we just keep using the node majority. We don't have to add the shared disk or disk as a node, as a vote. So this is what we are using, but I just describe the different situation that you might have to use. There are some good videos, articles that talks about the quorum. You should very heavily focus on the quorum configuration because you may end up in a situation where you have a split brain. If the number of votes are even, then your quorum is actually unstable, and your cluster is unstable, which may end up going back and forth from one node to another node, and you will see abnormal behavior. So please pay attention on your quorum configuration, which is a very important part of setting up an always on. So here is now the best part of this video is the demos. Here is this 11 different demos that I have put together. You will enjoy these, and once you see them, you will understand what I was talking about in the different slides. The first demo is if we have to use the virtual names. So I have configured these virtual names, and remember that the first virtual name is iOS instance, which is set for app 1, DM instance is set for app 2. So if I use iOS instance as the server name in the connection string, or the DM instance as the server name in the connection string, I should be landing on to POC1 for iOS instance and landing on POC2 if I connect to DM instance. So let's see that how it works. So let's connect to the first instance and see where do we land. I want to connect to iOS instance, and if I connect here, and I'm using the virtual name, so let's see that where I am landing here. So if I use the server name to see which server I am connected to, I'll see that I have connected to POC1. Now if I go ahead and connect to a different instance, which is a DM instance, and see what happens. So if I use the DM instance here in this case, and if I see that where I am connected, I will see that I am connected to POC2 server. So you've seen the first demo. Now look at the second demo, which says to fail over to local secondary and then connect using listener and ensure that connect to the read-write server. Read-write server is the primary server which you can use for read and write the data. So in our case, what we are doing basically is we are failing POC1 to POC3 and POC2 to POC3, and we will see if we make the connection using the listener name iOS instance, we'll be ending up connecting to POC3. If we make a connection to the DM instance, we'll be connecting to the POC3. So DM instance has an availability group. I call it AGTM, and iOS instance has also an availability group. So let's talk about this. So let's fail over our DM instance and iOS instance. So how you fail it over is actually you select the availability group and then you say failover, and it will give you the possible options. In our case, we have POC3 and POC4, and since POC3 is synchronized automatic failover, you see the check sign, but POC4 is asynchronous and is a manual failover. It says the warning. Warning is the possible data loss. So let's use this wizard to fail over the DM instance over to POC3, and I will actually make a connection quickly. There you go. It's going through setup scripts. You can generate the scripts and then you can run those scripts, but wizard, the reason I'm showing it so that you know and feel that how you can fail it over. Same thing you will do, it's fail it over. Let's do the failover of this guy, and same way, no difference. Choose the POC3 and then so once this fails is over, what we will do is to see if we make a connection, where do we land. So what will happen once it is failed over successfully, we are using the DM instance and making a connection here, and use the same query server name, and see we are landing into the POC3. Now if I go back here and if I connect to iOS instance, and if I make a connection here and I see that where I landed, you'll see that I landed to the POC3. So now we know that virtual name is very important for a client. They still be using the same server name to connect to the server, and the server is moved from POC1 to POC3 for app 1, and same thing for app 2, that it moved from POC2 to POC3, but the server name will remain the same. Now let's fail back these guys and see if we make a connection after that, what will happen. So I'm going to fail it over back. These guys, this time it is talking that I want to connect to POC1. I want to do the same thing for the other guy while it is first is running. Taking it along for some reason. So let's finish that guy. It came successfully. Let's give it some time. I don't know why it's taking long, but anyway, so it came back. And it is filling it back over. So now once this is failed over, we know that these instances are hosting into the right place, which is their initial primary. And if we make the connection at this time, let's see where we connected. So if we connect to the DM instance, and if we use this query to see where we are, the DM instance primary location was POC2, so we are landed to the right place. And if we go connect, they didn't close. If I go connect to iOS instance and I run that query, I'll see that I'm connected to POC1. So that's the second demo. Let's go and see what is the third demo. Let's go to the demo slide and see we have covered the first one and the second one, and the third one we also covered the third one actually. We fail back to the local primary, then connect using the listener or the virtual name, ensure that we are connecting to the right server. The fourth demo I want to cover, if I make any DDL or DML changes on the primary, it should flow to the local secondary as well as to the DR secondary. So we have local secondary POC3, DR secondary POC4, and the primary for app1 is POC1, primary for app2 is POC2. But I will not go and use the app2. I will just use the app1 for this demo. I don't need to use the two application. If it works on the application 1, it should work on application 2. For the demo purposes, I will be using app1. So let's see, I am connected to the app1, which is iOS instance, and see if where I am currently connected, which server I am connected to. So if I run that query, I'll see that I am connected to the first server, POC1, and I want to see that if there's a table called T1 in the database called iOS, and I see there's no such table. And I want to also see that table does not exist on any of the secondary. The secondaries for app1 is POC3, and I want to check if the table is there. Well, there's no table. And on the DR side, the secondary is POC4. So if I go connect to POC4 here and try to see the table there, I don't see the table is there. I'm coming back to my primary instance, which is POC1. Just want to ensure that we are on POC1, and I actually want to create a table T1, and I want to insert a record. Very simple query, just to show that if I create a table and add the data, it flows to the local secondary and the DR secondary. I just showed that it was not there, and if I run this query, it will insert the record, create the table, insert the record on primary. If I go back quickly on my local secondary, which is POC3, this is POC3. If I use to see that the server name is the right server name, here, and if I see if it's the right server name, POC3, and it was not there before, and if I run it, I'll see the table is there, the record is added. And if I go to POC4, which is the DR secondary, and ensure that this is right, and if I connect and see, the table is there. So you see that it is flowing from one side to another side. Now what if I actually fill this guy to its local secondary? So right now it is on the POC1, and I want to fill it over to basically its local secondary. Go and make the connection. Connect to the iOS instance, and iOS instance first was sitting on POC1, but now it is sitting on POC3, and I know that this is the record already there, and our secondary local instance is actually now POC1. POC1, if I go back here and see, this is POC1, and I want to copy this guy here and see that POC1 has data, and POC4 already has the data. Actually this is not there. Now if I insert another record, should it flow to the secondaries? So let's add another record here, and I want to run this using this query. It insert the record on POC3. Does it go to the local secondary POC1? I see, sure enough, I see the data there. If I go to the remote secondary, if I run this query, and I see that two records are there. So we have seen in our demo that if we fail over, it flows the data in the reverse direction, and if everything is on the primary, it flows accordingly. So I'm going to now POC1 for app 1, always on works. So our next demo is basically that if we shut down the primary server, which is POC1, and see what happens, does automatic failover kicks off. So let's see if that happens. We know our primary server is currently sitting on POC1 server. If you look at it, we'll see, well, this is the wrong thing. If I go back and run the server name, check, I'll see that I am connected to POC1. And if I go ahead and do 2. So let's stop the services here on POC1. If you look at this, is a POC1 server. If I stop these services, it should basically go and fail over my primary to the secondary. And if I go, I did not do anything here. I just stopped the services, and I came here. The existing connection that I was using, it was showing POC1. If you look at this here, it's POC1. If I execute this and reconnect it, I'll see the POC3. For the client, it is using the same virtual name or listener and connecting to the right instance, and I can do whatever I want to do. You know, I can select the data, I can insert the data, whatever I want to do. So I see I can insert the data here. Let's see, insert a record here, number 3, and see if the record flows. Well, one record is added, so my primary at this time is POC3. If I go to POC1, which is, I guess this one is, I'll see the third record come here. Well, this is POC1 is down, so it won't connect. So ignore that guy. Let's go to the POC4 and see if it flows there. If you run it, the record is there. So let's go and start the services back online here and manually fill back from POC3 to POC1. Assume that your POC1 server is back online and you want POC1 is your prepared server, so you want to fill it over. So basically the iOS instance is sitting there. iOS instance should be sitting on POC1 now. So if I am I'm connected to iOS instance. If I check the server name on this instance, I should be seeing it POC1. So we have covered our 6th demo, and actually the 7th as well. We start the SQL on primary and fail back from secondary to the primary. Backup preference, that's the next one. As I mentioned that you can actually make the backup on the secondary and any secondary. So you have an options to set the priority, which secondary server that you want to set the priority, and then you can make the backup there. So what does the script look like when you are setting up the backups priority? Basically this is the script that you can make, so enabling availability group level option on the primary. So in our case, this is the availability group name, and we want to say that we want to prefer the backup on the secondary only. And then we are saying that what are my priorities? We know that our secondaries, possible secondaries are 3 and 4. So we want to set the priority, 3. If you want to keep the backups locally, then 3 is my first priority. If I want to, and then 4 the second priority, and the first one, which is the primary server, I want to keep the third priority. However, if I want to keep my backups on the remote side, then my first priority will be POC4 will be my first priority. So it's your choice. Reason I'm discussing here is priority, so that you know that you can set the priority secondary. In this case, POC4. See that you can do the backups on the secondary. You can define your preferred, backup server. All can be done with few scripts. We are done till number 8. Number 9, this is one of the promising and the shiny feature of Always On. Now, what does it? Why I say shiny? For instance, if the users wants to connect to the secondary database server for your reporting purposes, in that case, we will be using the same virtual name or listener name to make a connection. But if you pass one of the connection string called application intent, and you define if the application intent is read-only, then you will be landing automatically to your right secondary for the read copies, for reading the data. So this is beauty. You have this option to keep using the same virtual name and just define the connection string. In the connection string, application intent equals to read only. You will be landing to the right server. So let's want to run this query to ensure that I am on POC1. And clearly, this is an important part. So TCP connection, server name iOS instance, port 1433, database iOS, application intent read only, multi-subnet failover equals true. This is also an important string in the connection. Multi-subnet failover equals true. Sometimes if your remote is on a different subnet, then if you pass this connection string, your making connection will be fast. And Microsoft recommends, regardless you are connecting to the local secondary or the remote secondary, you always use this multi-subnet failover equals true. So make the habit to use this. I copy that and I say, okay, I want to connect, but this time I want to connect using this connection string that I just showed you, and let's see where I land. So if I use this connection string and I check the server name, I see that, hey, I landed to POC3. So this is the beauty. It was not available before. Always On provides that flexibility. You can use a virtual name to connect to the read-only copy of the database on the fly, only if you pass the application intent equals read-only. So I hope so far you have enjoyed the demo. I want to take a break, and then next I will show you if I bring all the servers down on the primary side, which is POC1, POC2, POC3. What will happen? Because it is set to we use manual failover. You have to go through and do some cleanup, which is actually fixing the quorum, and then bringing the cluster up, because the cluster will down, because if you bring down POC 1, 2, 3 down, which have one board each, POC4 have no boards, then the cluster is confused. It's called brain split situation, where cluster is brain dead. And in that situation, you have to change the boards and assign one board to your POC4, which is the DR side server, and 0 to each of the primary side server, POC1, 2, 3, and then start the services on the cluster and then failover. I'll show you next that. So I brought down POC1, 2, 3 down. I just want to check it is the case. So you see that there's no reply on POC1. If I do this with 2, no reply on 2. If I do the same thing with 3, no reply on 3. And if I try to make a connection to the cluster, it's dead. It's showing that it's not able to connect. So if I again try to connect, is saying not able to connect. Anyway, so at this time I have set up some steps that we need to do, which is to start the cluster in force way. We have to force start the cluster, but before start the cluster, I just want to stop the services. Usually the services are already stopped, but this is always a good thing to do is to stop the services, and it will say that services are not running. So you have to now start the cluster with this command FQ, which is a force start, and even though if it is a brain split situation, it says I want to start the cluster regardless. It's starting the cluster. Once the cluster is start, well, I also want to show you that what is the current actually voting. The current voting is 111 for POC1, 2 and 3, 0 for 4. But if I have some PowerShell script that I wrote which shows the current setting. Now I want to change that setting so that POC4 has one board, and for that I have a script written which is in this case make SQL POC4 board. So if I run this script, it will change the settings, and if I go and view the voting, I'll see that the voting for POC1 is 0, 2, 0, 3, 0, and 4, 1. So now cluster is in good condition. So if I want to make a connection here, it should be able to connect just fine, but except this is warning saying that failure happened and all of those issues that it can report. But now cluster is ready, and you have fixed the quorum. Very simple, and I'll show you those scripts. Those are not very small few lines script in the demo. Now going back to the failover. What you have to do, if you come back to POC4, you have to use the connection POC4 first. Just for the demo purpose I'm showing you. You come to POC4 and say that, hey, my availability group for those two applications is in the resolving condition. What I need to do, I need to say failover one application at a time, and it's saying that it was set to use asynchronous commit main of failover. It's a possible data loss. You have no choice. You accept the condition, confirming failover with the potential data loss, and it will go and make your database available on your DR site for the first application, F1, and same thing you have to do for the second application, which is the DM instance. You go through the motion, fail it over. You can script this if you want. So anyway, so here, right here, you can script that. So now what we have done is that we have brought the primary side down and bring the second side up, fixing the cluster, failing over the replicas, and now our second side is up and running. So let's make a connection using the virtual name. So if I go and if I connect to DM iOS instance. And if I connect here and if I use so I am able to connect, and if I check where I am connected, I will see POC4. Same thing if I do and make a connections to DM instance. And if I make a connection here in the query and check where I am connected, I'm connected to the POC4 using the DM instance, right? So you see the failover, and you can read the data you want to, like you were reading the data before. In there you can say use iOS, go select start from T1 table that we created, and see what happens. You will see the data that we inserted there. Here you go. So you can do whatever you can do here, want to do, because that's now your primary server. Your site is down. At this time, if you want to fill back, I have some steps that I can show you, but the demo I cannot do because I don't have access to 1, 2, and 3 server to bring them online. But I can show you the steps. I have gone through the motion of these steps, but for now I cannot show you because I don't have access to bring those POC 1, 2, 3 down. So if in case you have to fail back to the primary, once your POC 1, 2, 3 are on, you have to fix the quorum. I have the PowerShell script for that, and that PowerShell script that I wrote is fix quorum. I'll share that with you. Once you fix the quorum, you can view it to make sure that the votes are right. 1 for POC1, 1 vote for POC2, 1 vote for POC3, and 0 vote for POC4. Then you have to go, same thing I did to failover, right click on the availability group of first app, launch the failover wizard, go through the motion, and then same thing with the second application, availability group, and you can connect using the same same listener name. So last thing that I want to share with you, the scripts. So you were seeing the view node script, the PowerShell script. So this is a script. Just pause your video, capture this script. That will show you how to view the nodes, votes for each node. Second, this is the script that I use for making POC4 as a vote. So I assign 1 vote for POC 4 and 0 vote for 1, 2, and 3. And then fix the quorum, which is opposite of make POC4 as a 1 vote, but this is an opposite. Fixing the quorum means bringing back online the primary site. So 1 vote for 1, 2, 3, and 0 for 4. So anyway, I hope that you have enjoyed this video. Any question that you have, you can email me. I would love to answer. My email address is au90remote@gmail.com.